Morning, folks. So basically, those of you that were here a couple of weeks ago would have seen the System 3 in a state of build, and I went through the boards. And as a part 2 to that, what I wanted to do today was just do a bit more of the software side and the sort of demo running side, so you can actually get some visual output rather than just look at the green of the circuit boards. But I'll touch a little bit on the hardware aspect as well, so that those that are more hardware oriented can get their fix too. So if I swing my laptop around with the camera on it, what I'll do is I'll try and start with, I don't know if you can see that, shout if you can't. Hopefully it should be coming out okay. I just wanted to show my System 1 because that's where I started in this project, and as the theme today as part 2 is actually, you know, programming and running the things rather than just sort of building them. I wanted to show a really useful utility from Mike Salmon that's running on a Raspberry Pi. This is a headless Raspberry Pi sitting in the office on our network. So if I can just reach around my screen. Basically, I've got some assembler code that I want to run on my System 1. So if I run nano. So this assembler code is basically just a simple display test, and you know, effectively a hello world. So what's really useful about that is, this particular setup is, if I run AS1 build, Mike's script on my assembly, what it will do is it will whir away in the background, and it's created a number of files, a list file which is really useful, a WAV file that actually basically plays through the tape port to actually load it in, or of course you can type it in. Sorry. Now if I look at the list file, I've got a nice set of assembly instructions. I can then go over to the System 1. I can actually go through the consecutive memory locations and enter those in. And then if I basically then execute that program from that address, I get my program running. So that's a quick demo. You know, as I touched on the System 1 build last time, here's, you know, a really useful sort of way of actually setting up, you know, the system and getting some code to bash into it. And of course, if I transfer over the WAV file from my Raspberry Pi onto my local machine, I can remember what the password was. I can then, oops. There we go. Basically transfer that over, and in the downloads folder, we have a WAV file that we've just compiled with the script, as you can hear. And that can then, that's an alternative for actually playing into the System 1. So again, just wanted to start with that as I started that last time. So that's the sort of the programming environment, if you like, very basic, but very sort of bare metal. You know exactly what's going on. And I found it brilliant for learning 6502 and actually sort of getting started with the System 1 family. And this was also a good springboard for creating the CPU card, which, now moving on to the System 3, hopefully you can see the setup there. If I shift chairs, that very same CPU card is actually, let's get that around. The very same CPU card is actually sitting in here running the system. So basically, in terms of executing, what I've done differently this time around for this demo is that you'll notice that the 8K RAM ROM board that I was demoing with the 4K basic last time, very similar to Atom basic, and I've got a debugger and assembler on there as well. Quite limited, obviously not very much program space, 4K and 4K of ROM on the system, but usable. So that's what I was using last time to actually demo the system running. This time round, what I've got in here is an evolution to this board, which is actually a 48K board. It looks very similar in layout. The address decoding is slightly different, but effectively I've got blocks 2, 4, 6, 8, A and C enabled. That actually enables me to not have to have EPROMs, but to actually load images into high memory to actually run more software. So I've actually got Acorn BBC Basic that I'm going to load into the System 3 to demo that. So one of the reasons I created this, not only a springboard from the System 1 to the System 3 to test the cards, but also I was sort of following through the evolutionary journey of maybe how Acorn would have developed their product. So the System 3 will go into the System 5, which is just sitting over there in the corner at the moment. And the BBC Basic, or New Basic as they developed. And it really gives you a feel of how the evolution went from machine to machine. I think I've stored, the basics on drive 2. This is effectively running a mode 7 equivalent screen with the SA5050 sort of teletext chip on it. Some of the DOS commands are reasonably familiar. Infall is just a way of just sort of cataloging the disk and giving you load addresses and sizes here. And you can see here I've got System Basic 1, 2, and 3. For this exercise, I'll run BBC Basic 2. So if I tell the operating system to run SBasic 2, it should load it into the execution address A000, which in my memory map is sitting quite nice and high up there above the program RAM. And there we go. We've got BBC Basic running on the system, all the usual sort of familiar items available, and I'll go into that in a minute. So now to get some programs running. So I think that's stored on drive. Call out to DOS from basic, just like on the BBC. And it's showing me on here, and what I'm looking for is a boot menu that basically reads the disk directory out of memory, just like, again, you can get on BBC Basic through sort of disk loaders. This is a very similar idea. The load address here is 3000, so if you look at page 3000, so that's where my program space starts. High mem, nice big chunk of RAM all the way up to A0000, which is got pretty much 32K of RAM to play with on the system. So if I chain my disk 1 menu program, processing it. This is only a 1 megahertz CPU. The System 5 is a 2 meg board, so it's a little bit of time to process. But nice colourful teletext display, and I can sort of pick my programs in the usual way. So if I run a colour demo, notice on this system there's no concept of turning the cursor off. I think, again, this idea came later in the evolution of the machine, but you can see it just driving some tests on the display here. Again, all written in BBC Basic. I'll go into that in a bit more in a second. Run up new. You can auto boot these disks as well. There's actually a way of setting the disk option and creating a boot script that actually gets that to run on break. But I haven't quite debugged to that yet, but we'll get there. You know, a practical times table program there. A couple of questions. So it's asking me 10 times 2, thank you, it's 20. 7s are 28. Brilliant. So little times table program there. So I would set my boot up to basically load in BASIC and run this program, but I'm doing it manually at the moment. Various other bits and pieces of software on there that I can run. Perhaps one interesting one we can look at that fits on the screen, don't know why it says that, is just a basic sort of counting program there, a countdown program. Now, I don't know if you can see that, the clarity of on the video, but those of you that are BBC Basic fans, obviously there's no concept of mode on this machine. I don't know if it's actually mapped. It brings up a colour, but certainly you can clear the screen. So basically here you can see it's got print tab implemented, it's got procs implemented, so it's got a procedure for sort of doing double height text, etc., etc. So really it's a really nice BBC Basic playground, and again this gives quite a lot of scope. Again, I could imagine it back in the day with new BASIC, etc., for developing from the BBC, getting the BBC up and bootstrapped and the BASIC debugged and tested. So not such a foreign environment the Acorn engineers I think had back in the day for developing the Beeb and all the machines that came after it. And hopefully you can see some of the familiarity that I was quite pleased to see of, if you do own a Beeb or an Electron, etc., you can see it sort of how its legacy came about. So in terms of the boards, then you've got the CPU boards I mentioned before. We've got the 40 by 25 display generation VDU board here going through a SCART, RGB SCART, the 48K memory board, and the floppy disk controller. And the memory and floppy disk controller, basically, I've used this system to actually test those builds in. When it gets to the system 5, so I've got a new backplane for that, which is a buffered backplane that takes the some CPU sort of frequency. It's a 24 megahertz, I think, crystal on the CPU card. And it's got basically sort of transferring a range of frequencies across the bus, 12, 8, 6, 4, 3 and 2 megahertz that can be picked up. And that can be used to synchronize the new VDU card. It's got onboard clock generation, but it can pick up through the CPU card as well. So I would be demonstrating the System 5 today, but the chip, the 6845 or the 68B45, I was hoping it to be, turned out to be a 1 megahertz version versus a 2 that I needed. So this is as much of the System 5 demo that we're getting today. But basically, yeah, the RAM board and the floppy disk controller go into this system. I'll get an 80 by 25 display, very similar looking to Node 0, and an upgrade 2 megahertz CPU. And the plan for this one is basically to have an Ethernet card board in it that I've already built, and basically turn that into a Acorn file server for the BBCs that I've got, and the other Acorn machines such as the RISC PC, etc. So that's basically part 2 of the demo. I hope that's been useful, perhaps insightful, and again a glimpse of history recreated of perhaps how Acorn would have had what sort of system Acorn would have had, forgive the pun, at their disposal to develop the machines we have today. So that's it. 15 minutes worth of demo. I guess we've got 15 minutes worth of questions, or we can finish early for a cup of tea. Either way, I'm not too fussed. Right, well, but happy to have any questions.
Excellent. So thank you very much for that, and absolutely bang on time on 15 minutes. So just to say, we're still recording this. So this is now Q&A section. So anyone wants to ask questions, fire away. But if they don't wish to appear on video, you can. There's an option in Zoom that you can stop video, so you can fire away and just ask a question like that. Otherwise, just go on mute if you just wish to lurk in the background whilst questions are asked. So yeah, fire away. Anyone? Questions?
And I'm happy to pull any boards out. Sorry to interrupt. Happy to pull any boards out and sort of hold it up to the camera if anyone's interested in a closer peek. I will say also, again, as I did last time, great shout out to Trev Ham on the forum for actually designing and implementing the majority of these boards. I think the only ones that I put together were the ones partly to give the Acorn keyboard that I've reconstructed an ability to run through USB to PCs as an alternative, and a PCB to implement the power supply. But the rest of the boards have come from him, and in fact a lot of the software on the demo that he's been working on as well. So great shout out to Trevor's good works in actually reconstructing or redesigning these systems for people to get hold of the boards like me and build them up and make systems, bring them back to life. So thanks to him for doing that. And as I say, in the last meeting I mentioned, where I started was System 1, and I actually used the Tiny CAD, I think, to lay out the board, and that took me a good couple of weeks just to lay out the System 1 board. And it's only as Trevor beat me to it that I sort of jumped onto that bandwagon, because my goal was really to learn how these systems worked and to get one, a System 5 file server up and running, which was my main goal. So anyone that came along with a ready to build circuit board was thankfully received. And I noticed that there are others on the forum as well, doing System 1s and System 3 implementations. Great learning experience for getting started with Acorn stuff, because it's so simple and so fixable. For most of the stuff I've got an oscilloscope that I probably needed 2 or 3 times to debug stuff, but the rest of it was just voltmeter and soldering iron and continuity checking, and it went together very nicely.
Any questions for Andy? I can think of one, though. You may well have answered it during the...
For me, it's very not so much a question, but just a comment. I just find it very, very impressive, to be able to pull all that together. And I think it's a great project to run with there. Certainly something I would be interested in doing if I had the time. Unfortunately, I think time's against me just now. But I just love seeing all these old systems getting pulled back together. So great project there.
I agree, and it's really recreating history, because some of the ICs on these boards are quite hard to come by, and you have to do quite a bit of detective work to work out the right ones. And the floppy disk controller, the Intel floppy disk controller, is 1979 stamped, and these things are becoming harder to come by. I mean, the good idea for some people are doing is moving the RAMs over from the standard was it 2115s half K RAMs to or less, I'm not sure what the capacity is on there, to for example on the RAM board 32K SRAM that's more modern, and to actually replace the I/O chips with the 6255 equivalent. So there is some modernisation that's required when chips have been stopped being manufactured for 20 years or so. But fortunately, in my case, with the exception of the RAM board with the SRAMs, most of the components are original. So this is pretty much a reconstruction of what people would have had back in the day, which is good fun.
Yeah. Apologies if this was maybe asked in the previous demo you gave. I wasn't able to see that, but the boards and that you are using there, did you get those manufactured, or did someone already done that for you?
So these were bought off so half and half. So Trev basically sent me the board, the flat packed boards, if you like, that he'd basically designed, and I just populated and built them. There are a couple of boards that I needed to sort of design, and I use PCBWay for my boards. I know others use sort of JC Part, but I mean, for me, PCBWay has been fantastic, because had 100% success from them, basically dropping stuff out of KiCad. They do the checking for you online. They basically give you a thumbs up, a question if a couple of tracks are a bit too close together, or they're not sure about where drill holes are going to go, etc. They're really quick to come back, and usually I get a sort of 2-week turnaround or less from getting the boards. And I'm in no way affiliated with PCBWay. I'm just saying that's my experience. And again, it was quite daunting, when I started the project, thinking I'm going to have to do a couple of my own boards to add to the ones that Trevor provided. But that's all part of the fun. It's all part of the learning experience of actually running KiCad, working out what Gerber files are and uploading them, and committing your money and hoping that what you'll get back is anywhere close. And actually seeing it spring into life is a great reward after the efforts. So I would, and again, it doesn't, saying you don't have the time. I mean, these boards were built up over a period of a couple of years. It was sort of like in little spurts of a couple of evenings every other week. More in the winter time. In the summertime, they get stuck in the plastic box and left, and other things happen. But this is one of these things that you can go back to. And you can park, and especially as they're single cards, it's nice to sort of pick up and put down. So again, thoroughly recommend it, and very therapeutic in times like this, where you've got a nice constrained problem to solve. Like the address isn't decoding properly on this card, or I can't quite get the frequency right on the video card on the timing, and have I got the right components in the right order, or do I need to add any delays anywhere, and getting the oscilloscope out. It's one of those things that it just takes your mind off anything. So it's very therapeutic, if nothing else, and quite rewarding, as I say, when it runs in the end. But that's the shame of it when you've got it running, is that you're looking for the next project. So I think surface mount is what I'm starting to dabble in now, and I've just gone back to PCBWay for a batch of the HDMI to RGB hoglets of boards. I've got 5 of those coming, because that's minimum order. And I'm going to have to try and surface mount the Xilinx, CPLD, and see how I get along with those. I've got 5 of those, so at least if I get one working board out, I'll be pleased. But this is obviously all through holes, so again, it's a nice progression as well for the learning curve. Is now I'm sort of confident enough to want to do the surface mount stuff, and get my BBC display and other machines' displays up to HDMI standard.
Yeah. The surface mount is a challenge. Can be a challenge. I've just moved on to doing surface mount stuff myself, but I'm generally getting that done by the PCB manufacturer. So and in the whole, I think it's been pretty successful. I had some some bad batches come back just as a coronavirus outbreak hit China, and I think they must have had an awful backlog, and I think they were rushing things out of their factory. But since then, things haven't been quite so bad, and things have been coming across fairly well. Yeah, so it's been good. It's been a journey for me as well. So certainly something I've enjoyed as well as I've progressed from the KiCad to the surface mount stuff, and it's been good, enjoyable.
Yeah. I'd say not bad for a software engineer. I thought to try and sort of well, I mean, I do digital hardware design, but that's nothing like this very analogy. What the heck's going on? There's no way to debug it apart from an oscilloscope type work, which is that's half the fun of. It's almost a shame in some respects where you plug something in and it works and you think, there's nothing else to do on this. If it doesn't work or it's half working, that in itself is a bit of fun to say, right, there must be, it must be a logical path to trace as to why it isn't actually coming up. And the way I'm building these systems up is a board at a time. As you can see, hopefully it came through in the demo, is that an incremental development on the build, and never, the golden rule is never try and make 2 changes at once. Always do 1 change at a time and then test, because you've complicated things unnecessarily if you do it in 2 hits, too many hits in one go before switching off.
Andy, I have a question, if I may. You may, I think you may have touched on it actually in your talk, but just a simple one really. So the boards, I think it's the System 3 that you were demoing on.
Yes, 3.
What were each of the cards' functions? There were quite a few cards on there.
Sure. Yeah. Let me switch off, and I'll pull them out quickly and show you. I'm going to unplug the mains as well because I don't want to stick my hands in the power supply. Right, we're safe. Okay, so safety first and all that. So yeah, this is the CPU card. I'll take the keyboard out of the way. So that basically is what's sitting under the keyboard and tape card on the System 1 I showed you, hence the relevance of the demo. The only difference is that the monitor proms have been swapped out for an Acorn DOS EEPROM, and the address changed to map over to that. And it's running DOS with 40S. So 40S is basically the code that, for the display card, which is this one. Again, that's just running into an BBC RGB SCART cable, and that's a little tinker that changes the dot clock that you have to get your oscilloscope on to debug to get the picture. There's the SAA 5050 teletext chip that you saw creating the colors. This is the 6845 display controller, the 1 megahertz version. So that's the VDU card. And then a couple of cards left. That's the 48K SRAM card. So everything that the basic and program space were, and the working space, the operating system, all on those chips there. And finally, we've got the floppy disk controller, so that's supporting the 2 double-sided 80-track drives, and this is your classic 8271, 1978, that one, floppy disk controller card there. So that and the RAM board will plug into the System 5. On the System 5, it's a new backplane that Acorn did for that, an 80 by 25 VDU card. The 2 meg 68B45 plugs in there, and then this one, the CPU card. There's the 6502A there running at 2 meg, and the 6522A sort of I/O chip there, as opposed to the original, very hard to come by. I think these ones came from Australia, would you believe? 8154s. I don't really need that one in there. I just sort of populated that in case I might use it one day, but that's the thing that interfaces with the keyboard. So those are the boards. The power supply, some might recognise. Leaving the back plane now with a power feed to the floppy drives. It is actually unplugged from the mains, so there we go, no sparks. So the power supply is basically one of these, I think it's PT65, isn't it, that you'd find feeding as a replacement for a master or a B, but there's kits available for that. I'm putting 5 12 volts into the backplane on that. So that's one of the boards I had sort of built up from PCB way that knocked together quite quickly. Yeah, so I think that's that's pretty much it. There's not much left then to dig into apart from the backplane itself, where you've got your buffered, if you populate the buffers, the buffered CPU slot to drive more cards. I was running it in unbuffered mode for that one, but the new board is actually buffered. It's buffered on the CPU card, so it should be able to drive more cards out of the box as being the next gen. Did that answer the question?
It's very comprehensively, Andy. So thank you for that. And for me, it's very, like you say, you can definitely sort of see the lineage of Acorn machines. I mean, I noted the 6845 chip, but which I don't think the Atom had, right? That was that the 6847 or something, which the Dragon had?
I think the Atom, yeah, slightly higher spec than that one, yeah.
But the 6845 is, but that's if I'm remembering correctly, that's the same chip as used in the BBC, and also there was a 6522 you mentioned, so the timer.
The 6522 is in the System 5, yeah. So again, you can see how, you know, chunks of the BBC, you know, the sort of if you like the ghosts of the Acorn system machines. You can look around the BBC circuit board and you can see where some of the ideas came from and some of the improvements, you know, with the teletext chip there that I think Chris Turner suggested that they put into the Beeb, and the AT25 mode, you know, on this card here with the 2 megahertz 6845 chip, creating the control for that, the timings for that.